Respected Head of Department, Professor Sunil Singhal, my colleagues, friends, very good evening and welcome all to this session on 4th day of Ruby Jubilee Lecture Series 2021. So far we have had very interesting talks on fuel cells, bioenergy, electric vehicles, etc. And today, with ever increasing prices of crude oil and followed by environmental concerns, it is needless to underline the importance of solar energy in present scenarios. And hence, we would like to extend our today's discussion and hear more on floating solar. The department is honored to have Ms. Marine Bernicot as our first speaker for today's theme. Ms. Marine from ISL Ingenierie, France, has almost 10 years of experience in dams as well as hydropower. She is very much involved in exploring synergies with other renewables, especially solar PV. She has studied various solar hydro hybridized projects in West Africa as well as pump storage hybridized schemes in Mayotte and Burkina Faso. She also works on risk mitigation when installing a floating PV plant on a dam reservoir. Within ISL, she leads hydropower and new energies department. She owns a master's degree in civil engineering from École Centrale of Lyon. Today's topic for the talk is floating solar being adopted across the globe, which is also evident from a growing number of projects around the world, especially in our country as well. This talk will provide a brief overview of floating solar industry with focuses on three topics. First one being the energy yields, profitability and hybridization with hydro. Second one is the floating PV design and specific challenges of dam reservoirs. And third one being the environmental and social impacts. So examples of existing and ongoing projects will also be given to illustrate the points raised. So with that brief introduction, I welcome Ms. Marine and request her to deliver the talk on an overview of floating solar industry. Ms. Marine, please.
Yes, thank you, Amir. I'll try to share my screen. Okay, can you see my presentation?
Yes, it's okay.
Okay, perfect. So thank you very much for the introduction. So I am Marine Bernicot from France. I come from ISL Ingenierie, which is a French engineering firm, which is about 35 years old. It was created originally by three experts coming from the dam and hydropower sector. So, I mean, you will notice from my presentation, but our background is really dam and hydropower. We also work on any topics related to water and water resource management. So that's how we came to floating solar. And I am myself very much involved in seeing how we can have hydropower and dams work together with floating solar. But you will see in my presentation that our background is dam. We are about 120 people based mostly in France, in 5 offices, and we work about half on French projects and foreign projects. Africa being one of our most active part of the world abroad, but we also come sometimes to India, sometimes to Southeast Asia. It really depends on the projects. I think that's enough for my company. Let's go directly towards the topic of today. So I'll try to provide you a brief overview of the floating solar industry. And as Amir said, separated in 4 different topics, a bit of context and figures about the floating PV industry, and then talking about energy generation, design of floating PV and challenges encountered, and environmental and social aspects. Is it, I'm just checking before going very fast into my presentation. Is it moving smoothly?
We can see.
Okay,
We can
hear
see.
me well. Okay, perfect. So I continue. A bit of context. According to IRENA, the International Renewable Energy Agency, the global installed capacity of floating PV in the world in 2020 is about 2.6 gigawatts, about 340 projects in about 35 countries. It's a really very fast growing sectors. In the last 3 years, it's 1.5 gigawatt of additional capacity. You can see it on the graph there. That was provided by SMAP and Ceres, supported by the World Bank. Unfortunately, it only goes up to 2018, but you can see how fast the figures are growing, and the growth speed is still the same, even increasing now. Until the end of 2020, China was definitely the largest market for floating PV, with the highest installed capacity. A few examples of recent projects. Of course, there are many more, but I wanted to take some specific examples. The first one is 181 gigawatts floating PV projects located on the west coast of Taiwan. At the moment, if it's not, because it's changing so fast, but I think it's the world's largest floating PV plant at the moment. It was commissioned in 2021, developed by China Energy. It's very interesting to note that this project has been developed in a super densely populated area. The second project is located in China, in Anhui province. It was commissioned in 2019. It was the previous largest one, and it's operated by the Three Gorge Group, the company that also operates the Three Gorge Dam, hydropower dam. The third project presented here is a project in the Netherlands that is one of the countries in Europe developing the more floating PV at the moment. It was commissioned in 2020. The interesting thing about this project is that they really made a specific effort on monitoring and mitigating the environmental and social impacts by installing elevated module to allow the air circulation at the surface of the water, using glass solar panels to ensure the light still reaches the water, to manage water quality. And they also installed biohut cages below the floating panels to feed the fishes and small animals in the lake. So that's an interesting project from the environmental and social point of view. And then the last project, I had to put one from France, is the first floating project that we have in France. It was developed by the company IPP Aqua Energy. It's a 17 megawatt project on the former Saint-Pic Lake in France. Brief view of what's to come in the next 3 years. Many projects are in the pipes, about 150 megawatts in Indonesia. That project is it's one identified project on Cirata Dam. It's a dam reservoir developed by Mazda. About a gigawatt of project in China, about a gigawatt of project in India too. I'm not going to go through India too much because I think Mr. Kumar will give a better view of what's happening in India at the moment on the floating PV sector. But yes, India is becoming a big player in this industry. South Korea is also having big ambitions in developing floating PV with 2 gigawatts planned in the next 3 years. So as you can see on this graph, it's a lot happening in Asia. And we also have some projects to come in Europe, in various countries, but most of them in the Netherlands, which is a small country, but with a lot of land pressure. That's why they go so much to the floating PV sector. So let's talk about energy and profitability. First question that we must ask is why floating PV instead of ground-mounted PV? If we compare figures, floating PV is about 50% more expensive than ground-mounted PV. The table on the right side of the slide was prepared by the World Bank and series in that guidebook that they emitted in 2019. You can see the figures. CapEx are a bit more expensive for floating PV. And also it's a new technology, meaning that you have risk while developing this technology. On the other hand, floating PV has some serious benefits. The fact that it lays on the water is improving the cooling effect, thus improving the efficiency of the PV panels, thus improving the energy production. It also reduces evaporation, enabling to save water. And this can be of particular interest in areas that are prone to water scarcity, and it also avoids land acquisition by using land that is not usable for any other purposes. So at the end, when you compare everything, you put that additional energy generation in the same box that those increased capex, you come to almost equivalent levelized cost of electricity between ground-mounted and floating PV, which is between 4 to 5 US dollar cents per kilowatt. Of course, as always, not all sites are similar. It really depends on the radiation, temperature, depth, waves, connection points, and so on. About energy yield, I wanted to emphasize two examples showing comparison that have been done on two different projects. The first one I wanted to talk about is Alto Bago in Portugal. This experimentation was conducted by EDP, the national energy producer. So it's a pilot project, 220 kilowatt, that was commissioned in 2016. And they compared the production of electricity between the floating plant on the lake and a roof PV plant on the rim next to the dam. And what they observe is an efficiency gain of approximately 5%. They said that maybe it might be a bit less because measurement was from really high irradiance, winter, and unexpected temperature. But since they observed that increase of 5% in the energy yield. The second example I wanted to talk about is not precisely a comparison between floating and terrestrial PV, but it's also an experimentation that has been conducted in Switzerland on Lac des Toules, which is an area really in the high mountains, and we would not really expect good results for PV projects, but I wanted to present it to you because I think in India you might also have this kind of location with a lot of snow and ice, and that could be interesting to know the technology. So they compared here monofacial traditional panels with bifacial alpine panels, and they found out that with bifacial panels, thanks to the reflection of the light on the snow and in the area with the water and everything, they could increase by about 50% the yield and the energy production of the PV plant in the mountain compared to a traditional power plant in the plain. The production they obtain in that power plant that is high in the mountain in the middle of the snowy area is equivalent to the one of a PV plant in North Algeria, in Africa, with a lot of sun. So it's quite impressive and really interesting to consider for PV in a mountainous area. The third point I wanted to talk to you about energy generation is an opportunity that offers floating PV when it's done on hydropower reservoir, namely hybridization. Hybridization basically consists of combining a hydropower plant and its reservoir with a solar power plant and making them work together. Hydropower with the reservoir provides what we call a dispatchable energy. Basically, you can turn it on and off whenever you want. And solar PV, on the contrary, is a fatal energy. You've got only electricity when the sun is here. The objective of the hybridization is to take advantage of the storage capacity that is offered by the reservoir in order to transform this fatal PV production into a more dispatchable energy, and then help the integration of this new PV that can be floating into the grid. Several levels of hybridization are possible, from simple collocation to complete hybridized solar hydro, acting as a unique 100% dispatchable power plant. The complementarity can be on many time scales. The minute one, cloud is passing by, solar power is quickly dropping, creating instabilities on the grid, and hydro can, under certain conditions, locally compensate the drop and by modulating the turbine flow. Should be done carefully, though, to cope with the turbine characteristic and avoid the quick flow variation downstream. The second one is the daily scale, to have the daily solar power curve match the daily electrical load curve. During daytime, sun is up, turbines are functioning at minimum, allowing to store water, and then this water can be turbinated at night at peak hours. So you can shift water from day to night. And the last time scale is the seasonal scale, where in many countries you have two very different seasons, a rainy one with less sun but with a lot of water filling up reservoirs, with a lot of hydro production, and then a dry season with a lot of sun but less and less hydro as the water levels are decreasing in the reservoirs. Some interesting benefits can be obtained from this complementarity between solar and hydro. The first one is to increase the firm capacity by displacing water from daytime to peak time. That is most of the time at night, at evening time, let's say. The second one is to save water that you can replace by solar. And that water put in areas prone to water scarcity be used for other purposes such as irrigation, thus help mitigating conflict around water, for example. And the third one is an induced benefits. By saving water, the average power level is increased in the reservoir, increasing the head, thus the hydropower production. On Manantali example in Mali, we managed to show that by optimizing the reservoir management curve, thanks to hybridization, they could produce up to 5% more hydropower with the same amount of water available. So that's quite a lot, actually. So that concept of hybridization is attractive: increase of PV penetration on the grid, firm capacity, water saving, mutualization of electrical equipment, storage solution. But it also brings constraint, and it's not that easy as always. You can have quick variation of downstream flow and associated environmental and social impacts, hydro equipment fatigue, because of repetitive stops and go. It can also compete with other existing use of the reservoir if not managed properly, or lead to loss of power by spilling over. It complexifies the operation with a high level of communication required between hydro and PV. The right balance is not easy to find, probably that's why we don't see so many hybridized projects so far. But we start seeing first project being implemented in Albania, in Europe, in China, and in Portugal on Alqueva power plant. Let's go to design and challenges. A short insight first of design choices and design technologies that exist for floating PV. The first one is the bank anchoring. So basically, you can have different types of anchors for different types of floating PV situation, different types of reservoir and everything. So the first one is you can anchor your floating PV on the bank. You have an example at the lower part of the image. You can also anchor your floating PV on the bottom, and then on the bottom use dead weight concrete blocks or steel anchors, or helical or screwed anchors that really dig themselves into the ground. It really depends on geotechnical conditions. The type of cables that you will use will also depend on geotechnical conditions, on mooring, on every condition of the site. You can have different materials for those mooring lines with chain, polyester ropes, steel wire. And then you can mutualize those anchors in some specific points, or have many different anchors located one close to one other one. This mutualization depends on geotechnical conditions, of course, and also the type of floaters. And you will see that there's not only one type of floaters. Different floaters exist. We can basically sort them in three families. The first one is individual floaters. I think the most famous one now is the one supplied by ISL. So basically, each PV panel is located on its own floater, and then each floater is connected to the next one through connecting pin. Second family is what we call Poutounists. So basically, on those technologies, the floating PV panels, they are located on a rigid, or at least a common structure that will handle the efforts coming from the anchors. So each panel is not set on an individual floater. The floater is carrying the whole structures in one block. And then we have a third family that is a bit in between, where you have floaters crossing each PV panel, and sharing efforts between each panel. You have also some typical example. This example down at the left bottom of the presentation is a floating PV plant that is rotating to follow the sun around a central pile. And that one is an example of the ocean technology, where the PV panels they lay down on a whole structure that is floating on the reservoir. So as you can see, there are many different technologies of floaters, and for each floats technology, you will have a specific anchor design that need to be designed together with the float technology, because you will not have the same anchors if you use the individual floaters technology, where the efforts need to go through every connecting pin, or if you need to connect and to anchor the whole pontoon of this family of floaters. So it's really a whole floats and anchors and mooring systems have to be designed together according to each site specification. So those site specifications, what are they? They depend on soil conditions, the size of the area, the admissible loads on floaters, wind, water level variation, etc. Many data should be taken in account to propose the proper combination of floaters and mooring design and anchors. I just want to give a small insight of additional challenges that are brought by floating PV on dam reservoirs, because you have specific topography. So around the reservoir, with most of the time a specific channel for the wind, which will increase the wind velocity and make it difficult to compute and to measure. You can also have higher waves because of the larger reservoir, and also stronger waves that will accelerate the fatigue on the floating PV structures. Anchoring can also be more challenging because of deeper reservoir and less known bathymetric and geotechnical conditions. because also of higher level water level variation in the reservoir that can imply specific design to be able to keep the tension in the cable and prevent the structure from drifting. So basically, floating PV, they are subject to some specific main loads, wind that applies directly on the PV panel, waves that will apply on the floating structures, and current that will also apply on the floating structures. Current, most time it's neglectable, and so most of the efforts and the main loads will come from wind and waves. Waves are generated by wind, so basically the wind is the most important load that will apply on your floating PV system. For given wind, then you can compute the loads that will be applied to the floating PV panels thanks to literature. But then how to choose the wind and or another natural event that will create load on the structure, how to choose this intensity. And you need to think about it from a risk analysis perspective. In the case of a floating PV and any water body with no dam, in case of failure, what happened? I only lose my investment. Electricity generation will stop, but it remains an investor risk into the lifetime of the floating PV plants. Typically, they will accept a probability of 10-2 and consider event with a return period of 10 to 100 years. Second case, we are on a dam reservoir, and it's a bit different because in case of anchors or structure failure, you will also lose your production, but you can also, if the floating structure goes away, you can have obstruction of the spillway or create other damages on the dam that could eventually trigger the main safety barriers of the dam, potentially leading to dam failure. And in that case, the consequences are completely different, and you should, the consequences in terms of, in case of failure, are much bigger. Dam safety standards imposed to be protected against events with a return period of 1,000 to 100,000 years, depending on type and size of dam. So you see that we are not really on the same scale. And floating PV developers so far, they're not well aware of that difference, and they tend to consider dam reservoir similar to any other water bodies, since you have a difference in terms of consequences. So if we look at what you must be careful of when you do floating PV on a dam reservoir, is to meet the required safety criteria. You have two options for that. The first one is to reduce the floating PV failure probability. Or option 2 is to disconnect floating PV safety requirement from dam safety requirement. And probably that's the wiser to do. Try to hide safety barriers in case of the floating PV fails, to prevent and to protect your dam and your spillway from any obstruction. In the world, there's no formal regulation so far on this specific subject of floating PV and dam reservoir. And the best option will probably be, as always, a smart combination of everything, meaning reducing the floating PV failure probability and disconnect floating PV safety requirement from dam safety requirement and protecting your dam. That's the most important. Last point, environmental and social aspects. 3 different topics will be discussed here. The first one is the physical environment. Second is biological environment, and third one is social environment. The first quite important impact that is expected by floating PV when installed on a water body is that while installing the panels, you create a barrier to sun and wind that cannot access to the surface of the water as they used to do beforehand in the initial configuration. And that has an impact on stratification and water quality. This graphic really synthesizes everything. basically what happened is that your layer of oxygenation and the mixed layer depths become shallower, and the water temperature decrease below the floating PV as there are less light and less sun coming to the water. This can be a negative impact, but this can also, in some configuration, can be seen as an opportunity to mitigate the effects of climate change on water bodies, where in some configuration, you start to see that with increased temperature, you also increase the water temperature in the water bodies, and this can have also negative effects on the physical environment. So it's a balance. It can be a negative. I mean, floating PV panels can have a negative impact on the water bodies, but they could also be used as an opportunity to mitigate those effects of increased temperature brought by climate change. Second impacts are biological. So the first one, they're directly linked to that modification of physical environment. When you have more shading, you have less plants at the bottom of the reservoir and more algae that will grow, so it will modify your environment. Water quality change can also impact the biological environment, such as the thermal structure, so have an impact on biology, such as species or other vegetal and animal species in the reservoir. Another impact that is most of the time a good impact of floating PV on reservoirs is to reduce evaporation by reducing the action of sun plus wind on the reservoir. It reduces evaporation and saves water. In some situations, when there is a wide area of the reservoir that is covered by the floating PV, it can help reducing wind and current at the surface of the reservoir, thus reducing bank erosion around the reservoir and giving more space to local species, local vegetation to grow more and to be less harmed by waves, for example. So this can be a benefit from PV panels. Third impact is the social impacts. Those are typical impacts that you can expect. When you install floating PV on a reservoir, you reduce the water navigation area, and you increase risk to have any elements, boat or anything to have a collision with your floating PV panel. You will change the visual appearance of the landscape. You will reduce the access to water bodies for fishing. The photo that I've put on the right part of the slide is an example of Cirata Reservoir in Indonesia, where they want to install 145 megawatt of floating PV. This reservoir is already a lot used for fishing, so this is a social impact that should not be neglected. You will have impact for tourism, and in the case of hybridization, you can also have quick variation of downstream flow, release downstream flow, downstream of the reservoir of the hydropower plant. Those one are quite positive impacts. Floating PV does not require any additional land. You use a land that is not usable for any other purposes, so it reduces land use pressure. And we start seeing this already. The countries that are going the faster towards floating are countries with a high density of population, and they need new space, and they cannot install ground-mounted PV because it will compete with lands with other use for the land. It has a low CO2 and greenhouse gas emission, and when combined with hydro, so through hybridization, enhances those gains, meaning that you will, for the same use of land, you will produce more energy than hydropower alone or PV alone. You will combine both hydro and PV on the same land use. So you decrease the global footprint when you relate it to the occupied surface, surface, and it's the same with the greenhouse gases emission. You will decrease it per kilowatt, related to the energy generation, because you make a better use of the same amount of land. How to mitigate those effects? There are many options, but they are still not very well known and well measured. You can work on the percentage of coverage of your lake by the floating PV panel. If you decrease the coverage, you will have less impact. You can elevate your module to allow a good air circulation between your floating PV panels and the water body. You can use glass solar panels to ensure the light still reaches the water. That's what they installed in Netherlands in the project I've presented in introduction. You can prepare feeding station for fishes and vertebrates in the lake to compensate the modification in their habitat, and so on. It's very case dependent, and as always. And as I was saying before, it's still a new field, it's still a new industry, and we lack data and lesson from case study to support those environmental and social impact assessments. So the first and most important point would be to monitor fish population, water quality, and so on, to know better those impacts and to find a good way to mitigate them. I'm not going to take too long commenting that image, but I thought it was important to put it back here. It's a really good sum up that were prepared by SMAP and Ceres in their overview of the floating PV industry. It summarized everything that I've talked until now in this pitch: evaporation reduction, land requirements, challenges for design and technical design, increased energy from cooling water effects, reduction, impact in the algae growth, and so on. It's a good synthesis, and it's good if you can have it with you if you are asking yourself questions about floating PV. I'm done with the presentation. I just wanted to give you some very useful reference if you want to dig in the subject. So those two documents, SMAP, were Sun Meets Water, that were prepared by Ceres and the World Bank, that are very enlightful regarding the floating PV industry. One book published by Elsevier that is called Floating PV Plants, that is collecting and gathering many experimentation and data that we're conducting on floating PV. It's really interesting. That recommended practice wrote by the NV regarding floating PV anchors design, and some other articles. I also wanted to give a special thank you to my colleagues at ISL, the World Bank Series, for their work, and also all participants of that conference that we had 2 weeks ago, Solar Hydro 2021, which really helped me to prepare that conference. I'm happy to answer any questions. Sorry, it took a bit longer than planned, but it was a lot of topics to talk about.
Thank you, Marine. It was a very nice talk. I'm sure students and others have enjoyed and realized where the future lies. We will take questions and doubts from the audience. There's one question in the chat. If you can answer to that question in the chat, if you can access that. Or I can read it out for you.
Yeah, okay.
I'll do it. So it says the dredging of silt from hydropower plant reservoir is an important activity to maintain the reservoir's capacity. Will floating solar installation affect the usual dredging operation?
It is true that floating solar would make dredging activities more complicated, because you will need to access or empty the reservoir and access below the floating PV panels. But in reality, from my knowledge, dredging of silt is not the most commonly used technology to protect any reservoir from silting, because the materials and the volumes are so big, it would take a lot of time and would be really expensive. What we really prefer doing most of the time is integrating in the dam design some flushing gates that will help you manage those siltings by the time. Because if you let them accumulate, it would be too complicated and you will have big challenges to define where to put those sediments, because most of them they would be polluted, they would be difficult to handle. So you would prefer planning from the beginning in your dam a flushing gate and an operating procedure to manage those silt properly, instead of having them accumulated in the reservoir and having to mechanically remove them. But it's true that floating PV would have an impact on such activity if needed.
Okay, I hope that answers the question. Any more doubts?
I would like to ask if others, please. First of all, others, please. If not, I'd like to ask Merrick. You see, we have raging couple of risk safety issues towards the dams, as we can see many things. And as you know, the dam owners normally are the government and irrigation department, and very few are the hydro people, but most of them are other than hydro, irrigation or drinking water, other purpose. So when we raise some kind of safety issues, then they will be not only keen, they will not be keen, but also they would like to avoid this solar photovoltaic. So since do you think there is something happening towards writing the guidelines, or people are gathering somewhere, people can think of that some guidelines may come in 1 year, 2 years time or sometime? So do you have any idea on that, please?
Yes, that's a really important point to be raised, and that's actually why I believe some of the projects are being slowed down on dam reservoirs, because the operators, they're concerned for the safety of their dams. I know that I called through the committee T, so Innovative and Challenges. I don't know the exact name of that group, but Innovating Solution on dam reservoirs is really focusing this term on impacts of floating PV on dam reservoir, and will issue a bulletin. So that would be a first step for guidelines on how to handle the safety problems raised by floating PV towards the dam installations. So we will have this document. It's being prepared. I'm not sure about the schedule, but I would say by the end of this year or next year, that bulletin should be ready.
Another thing is that that will be good. These guidelines, when it comes from ICOL, perhaps since most of the countries are member of the ICOL, so perhaps then acceptability by the government or by the dam owners will be relatively good. Something about this performance, you mentioned of the example of one, I think 10 megawatt example, where you said that performance has improved by 5% in terms of efficiency. But then is it what kind of climate condition? Because in different climate conditions, especially if you are in a humid area, the performance is still not necessarily that it will increase, not necessarily. Sometimes, so there, I think, do you have any kind of idea on that?
I don't have any data in my mind at the moment. It's true that it's site dependent, and dry area will have better results, and clear area will have better results than tropical and humid area. I don't have specific figures for tropical and humid area, but In general, it was noted that increase of the yield energy. Of course, yes, it must be balanced and probably tested in many different type of climates. I think there is another question in the chat. As floating solar can block mixing of oxygen and solar radiation, can it impact on aquatic ecosystems? Yes, yes, that's exactly the point. By reducing the sun penetration in the water and the wind action on the water, it's modifying the physical environment of the lake, and it can have an impact on the aquatic ecosystem. It will have an impact on aquatic plants, aquatic algae, and also probably fishes and small vertebrates that can live in the lake. This is once again site dependent, because of course, if you only cover a few % of your reservoir by a floating PV plant, the impact will be much smaller than if you cover like 50% or 75% of your reservoir by the floating PV plant. So it's really dependent. I mean, I think the most important factor for this impact would be the size of your floating PV plant compared to the size of the surface of the reservoir. There is another question. Do you think floating solar can go well along with big WWTP?
Wastewater treatment. Wastewater treatment plants.
I would say I'm not really familiar with wastewater treatment plants. It's not my main background, but a quick answer maybe would be, I think it depends on the technology. And I would say that for technology that needs a lot of irradiation to remove bacteria and clean the water, that would not be such a good combination, because the PV panel, floating PV panel, will block the sun. I'm not so familiar with other technologies to answer properly to that question. I apologize.
So, Professor
Okay.
Amit?
Yes. So if there are no more questions, let us move on. Thank you, Mrs. Marin. Thank you so much for your talk. Yeah, moving on, I now request our second speaker, Professor Arun Kumar, Department of Hydro and Renewable Energy, to deliver his talk on floating solar PV, Indian experience, challenges, and barriers. Professor Arun Kumar, please.
Are you able to see?
Yes,
yes,
can see.
Okay, very good. So I'll be talking more on policy part, or and regulatory part for Indian context. It is a floating PV, and I would say that I'll be talking on this. And so with this, I like to say what are the opportunities also. And Marin has very well presented the whole talk in terms of design aspects, technical aspects, and then environmental aspects. But I'll be talking more on the aspects which, as a policy, regulatory, technical, investment point of view in India is there. So, well, that's it. India is third largest producer and consumer of electricity globally, with annual production of say 1,200 to 1,350 terawatt. And we have about 382 gigawatt, where majority still is in thermal, and about 141 of renewable, and out of that, something about 36% is from hydro, and this 28% actually going from quite rapidly. In fact, in terms of expectations are going very high. Consumption is also rising by 6%. And if we talk about the Indian commitment of transition from normal power to RE, we're going in a big way. About 35% of energy requirement by the year 2030 is committed by Government of India, that it should be from non-fossil, and in the non-fossil, solar is going to play a big role. And 175 gigawatt of renewable is seeing from this year and 450 in the solar. When we talk about floating solar, let me also mention that India is one of the largest dam owned country, where over roughly 5,200 already existing, about 400, so something about 5,600 dams or 700 dams are there, and they are large dams. When I say large dam, that means they have a good reservoir and they have a good height, or less than, more than 15-meter height as defined by ICOR. So we have about 18,000 square kilometer of area and so much of megawatt or 200 gigawatt potential. And if you look at the map which has been prepared under the study, under a report which is a CARI and World Bank and other people have prepared, so you can see there are many states which has got a large potential of this thermal power, this floating solar. So, and also they have studied in terms of the variation during different seasons, because Indian water is water is quite not uniform. I mean, we get rains in during 2 months or 40 days, and we use 365 days. So there are about 15 floating solar projects which have been already executed or they are under pipeline. So something about 1830 megawatt of the plant, but many of them are a part of hydro reservoirs. And one of the projects of Bernicot, which is doing a round-the-clock kind of power commitment, with 1200 megawatt of pump storage, has got floating solar about 45 megawatt on each reservoir, and then 3,000 megawatt on the land and 500 wind. So it's a very nice example of a very good hybrid project which is under construction, and by 2023, since hydropower execution takes time, so it's expected to be completed by that time. This is a list which I have gathered along with my colleagues from the power companies. These are central power companies, NTPC, which is by large, you can see from they started with 0.1, 1, 2,500. So they're going from very single digits or less than 1, then going into the single digit, down double digit, now triple digit. So many projects are going, and SPCs are going also. There are SECI, and there are Bernicot. So many projects are coming up. So that's what about 1,830 megawatt. So, but none of them in the wastewater. And as I will agree, or I would like to just to support what Marine has said, that wastewater treatment is more complicated in terms of water quality, because acidic and all that, and also there is certain requirement of air, certain requirement of mixing. So waste distillation pot also requires certain intervention of water, I mean the solar light, sunlight and air mixing. So I doubt very much of that is going to happen. But since we have more opportunity on dams, which I said that water bodies, lakes, perhaps once that will finish, then we will go there. So you can see this is some examples of countries which is already, they have been considered commissioned very recently, and you can see they are thermal power plants, so they have big reservoir for their raw water requirement for cooling, etc. And this is where you can see some of the plants, like this one is 100 megawatts and 92. So they are going, like I just said, that is in the beginning. If you see the list of the project, if you see here, even up to 500 megawatt kind of power plants are under pipeline or under execution. They have recently tendered, but of course these lakes are very large lakes. And I also support that not more than 5% to 10% of reservoir area should be covered with the floating solar, because if you cover with more, then obviously you are under giving the more problem to the aquatic life and other environmental issues. So I say that reference which he has given, they also say that you have 5% or maximum 10%, not more than that, because but people have done more, but so that is the things comes up. In terms of technical challenges, she has mentioned very nicely, but I would like to just say very nicely because not much of historical evidences are available. So guidelines are not available. Safety requirements of electrical components, since it is underwater, they require good requirement. Anchoring, mooring is a constant. There are variety of types depending on the site-specific conditions, water conditions, geological, geotechnical conditions. You have to go for it. You have to carry out a lot of surveys. Bathymetry surveys many times are not available. Seasonal variations, quantum of trash, especially our Himalayan belt has a lot of trash and sediment. So that is also a big issue. The material life testing, certification, institutional mechanisms, since most of them are the government or anybody would like to see their product lies goes a long way. Supply chain is not very much established. So when you have the spotting orders, your supply chain does not give you optimum or cheaper cost. But people believe that in the next 3-4 years, the cost of the floating solar will be at par with land-based solar. So this is what many experts believe. Because by the time if supply chain is properly integrated, all these technical challenges, specifications, then there are regulatory challenges in terms of failure of anchors. She has said very well the design and installation operator floating may conflict sometimes or dam owners, various components, electrical components, and so safety requirements are very high. Components like floating platforms, cable, etc., biofuel fouling, corrosion, degradation, all that required. So there is a lot of hesitancy, initial hesitancy by the dam owners to place allow the floating solar in the so that we say because they take a lot of time. Unexpected behavior of this component can cause safety issues, the blocking in spillways. There are regulatory challenges because in India, for example, not only in India, there may be in many places, the dam owners are water supply people, irrigation people, fisheries, drinking water, water resources. So there is a lot of time consuming when if you want to do it, it takes because the land, everybody knows the land belongs to party A. But in water, many times there are multiple users, multiple stakeholders, and getting a clearance from everybody takes a lot of time consuming. There is no standard agreement available for right of water rights. So there is a policy requirements are there, regulatory requirements are there, standard technical specification for materials, floats, etc. are not available. Supply chain, including manufacturing, that's why some kind of regulations should be available. Preparation of the reports, because they also take time consuming. You require experts because everybody is not expert in the area. And floating is going to increase in future because off-river TSP schemes may come up. There are many non-traditional sites may come up. Experience sharing of this floating solar, I think, is the one which regulatory should bring it out. There are policy administration issues that we should have opening a single window clearances, because if you go to more than 20 windows to get project cleared, then it's quite difficult. The state government should need to have some special task force to clear the projects. There should be some database available. Water saved, I think everybody will agree that there is certain level, certain quantity of water saving by floating solar. So now water saving, is it in benefit of what? Should it not be trade-off? Like it should not be, instead of water use charges, in fact, one should pay to the floating solar fellow some money because he's saving the water. Water is expensive and water has got money. So, and also right now the capital cost, I think, though my guess is 20%, though Marine has presented, I think, from 62 cents to 72 cents, something like that. So about 10-12%. But my guess is, this may vary, depending on the locations, maybe 15%, 20%, and sometimes it may not vary also. But future scenario is that people expecting that they will be the same. Floating solar blocks some kind of land, sunlight, wind, etc., which environmental issues are there, and more work is being done, more studies are coming up in future. And I would like to say, when we should take a pinch of salt also, because nothing comes free. So you cannot expect anything without some impact, but you have to see that what impacts, whether they are major impact, then we should not do it. If there are minor impact for that region, she has said that we should go for lesser coverage. So 10%, 5% is considered to be, does not give much impact. There may be impact on local bird population. There could be environmental impact some during construction stage. There could be aquatic life due to shading. There could be some pontoon water pockets may form. There may be some leakage of lubrication and chemicals, which may happen a little bit. There may be some also in conflict with some leisure activities like water sports and other things. And then there could be some mitigation measures. You can give more spacing between panels so that the water sunlight can go and we reduce shading. The impact of water quality depends on water retention time, constant monitoring of changes in the microbiology, algae, and local bird populations are also there. One of the points which has been recently discussed in the hydrosolar conference, where that we can have some high copper level directly below solar panel may suppress the growth of algae, so algal formation can be stopped. I'd say that it's not much of details available, but people are working very hard on this as new technology coming up, and also reduce impact on downstream ecosystem so that hybrid operation should not be negative. And like we also mentioned, the investment climate is very conducive in India for renewable energy, solar and wind. And FP system can contribute reduction in water operations so that one can make a trading, like if I'm your water, so why don't you give me some money? I mean, with that, so that may happen. Still, FP is considered risky because of certain uncertainties. The World Bank recently supported SECI, were one of the solar energy corporation for leveraging international knowledge and best practices. So they did some studies, the mapping of floating solar, detailed assessment of some 100 water bodies, and some feasibility-based case studies for one of the projects for 500 megawatt, and some kind of potential studies which has been supported by the World Bank. So what's the way forward? I think we require scaling up, upscaling, and speedy implementation in the country. So at government at both central and state level need to design a good clear policy so that people don't spend time here and there. Floating solar should be part of solar hydro project. It will be designed to minimize environmental impacts. Performance evaluation in terms of power generation, if it is enhancing the power by certain level, and if it is giving a negative impact of anything, they should be studied, evaluated, and shared, so that when people decide about this floating solar, it is a well-considered decision. And also one should take a creation of of floating solar, including off river and other side. I get acknowledged because not of my institution, because I get a lot of input from NTPC, NSPC, and SECI, and one specialist from Surabhi from World Bank. So, and in fact, I presented more or less same paper during this last 2 days international conference of solar and hydro. So with this, I like to say thank you. This is our building, which is on the top, which is our administrative building. It looks like a White House. It was built in 1850. This building was built in 1850 only by bricks. There is no concrete has been used in that. So with this, I close my, PPTs, and we look forward the question, and then we like to have a more interaction with Marine and others, please. So right now I have completed. So please go ahead with the questions, please.
Thank you, Professor Kumar. Any questions from the audience, please?
So, Professor Arun Kumar, this is Vanshu. So, sir, what are the research areas that we should look at in this space right now?
Professor, Marine, would you like to say, since you talked about more on the research part or the design part, would you like to initiate this, discussion? I'd like to respond this.
Yes, why not? I can start, and maybe you can complete. I would say 2 topics should be investigated more. The first one is linked to environmental and social impacts. I think it's really important that the first projects are well monitored in terms of water quality, in terms of aquatic life activity, in terms of water temperature, evaporation, and all those impacts, and maybe also add to those this monitoring the energy yield modification due to the fact that it's floating. So probably the role of university could be to try to work together with the private investor to propose their services, to do some kind of research and development or finance or work on that monitoring part to help them, because sometimes the private investors don't see the next steps. They only see short term. So that could be a good partnership between university and IPPs, private investors, to use their project as a pilot project to learn more and to facilitate the next coming projects, because they will have more data. So that is the first point. And the second point would be that maybe it's a bit more difficult from the university point of view, but I would say it is related to safety towards them. And of course, the dam owner, they should be ensured that the floating PV plant will not harm the dam. But in some countries like France or Indonesia, now national regulations, they start to impose and to ask the IPPs and the developers to prove and to conduct risk assessment analysis to show that indeed in their design, they have put every barrier in place such so that the floating PV plant does not harm the dam itself, either with design criteria, either by adding additional safety barriers close to the dam. In some countries, they already start to have those regulations, so private investor will be forced to go for that. But maybe university with the Indian Institute, Indian Committee of Dam, I don't know if there is any, they could work together on good practices and how to convert those international guidelines that are to come into national applicable guidelines that could be good for India and that could work for India.
I think Madeline has very well described the two things, because environmental social aspect comes in a very dominating manner. And if you cover a large section, if you have a small part, it's fine. But today, environmental and social has become a quite dominating area of, and anything happens. Let me tell you, Himanshu, that one of the projects in our state has been not permitted, has been disbanded. It has been stopped because it was going to give a lot of environmental impact, so they have stopped. Let me also add some of the more research areas. One is the one like when you have the water, this water electrical aspects of safety. Electrical aspect of safety in India is because if you start using the marine kind of or other, they are quite expensive. So we have to ensure that safety aspects are also adhered to electrical safety aspect. The second is, if you talk about power system point of it, this hybrid portion will be a matter, because you have dams, you have the hydropower, you have a pump storage, you have the solar, and they are so hybrid part can be another area of research where we can think of that how they are going to impact the grid, or how the market is going to be there, how the business models should be developed for this one. And in terms of safety, in terms of even design, I like to also throw in design, when you have there are waves of even 2.5 feet or 75 centimeter kind of waves are there in some situations. So those are also, you require a good structure, and the structure has to go up and down. You had to be make some kind of a good maybe laboratory model. You had to carry out, like we do, a physical model for sediment or dam safety in terms of, so we have to go those areas also. And I would like to say, since it's an emerging area, there will be more windows will come as we go. Hesitancy certainly will be there next 2, 3, 4 years till all these guidelines, specifications comes in the market, safety standards comes in the market, the supply chain come in the market. Still there will be initial hesitancy will be there. So this was, I think, a long explanation, but I would like to say this is what is likely to happen.
Okay. Thank you, Professor Kumar, and thank you, Dr. Bernicot. Thank you.
Any more questions? Maybe 1 or 2 quick questions, please.
Professor Rhythm, are you there? Professor Rhythm? Pronit, do you have any question in your mind?
No, sir.
Pronit? Okay, very good. Professor Saini? All right.
Yeah. Actually, it's very nice informations and related to you can say this technical and regulatory and other issues. It's very nice talk we had, and if you ask me that if I put some questions or query, so my query is that what is the reason behind that in India this technology is not just coming up with the space, like if you compare with this land-based solar photovoltaic or solar systems. So that if you can give some light on that aspect, because we are just thinking about this, that the pace should be picked up.
Yes, like we mentioned you, first of all, there are 3 things are there. One is the HVAC costly by 15 to 20%. That's number 1. Still, the water bodies are owned by the government institutions, where the land can be easily procured, where and getting the water rights from the and using the water body, which is to take a lot of time. And there is third is hesitancy is there. Still hesitancy is there. That is how so far the projects have been only taken by the central public utilities, because they are the one who can still take more risk in a bigger way compared to one. So I would say that it is like a wait and watch, and I think next 2, 3 years, once these guidelines comes into market, I mean, as dam owners will see them, this hesitancy will be over in next 2 years. My guess is after 2 years, there will be more studies will be available. People will be more confident and more comfortable with it. Right now, comfort level is not there. It's not
Thank
there.
you. Thank you.
Marine, you would like to add to this question something on this hesitancy point of it?
No, I think it's a good reason. The lack of guideline and the lack of return of experience it's slowing down the process for sure. So it's evident that that the more project will be commissioned, the more project will come. I also have maybe a small additional question. I was wondering, but I'm not familiar with the whole India territory, but I think India is quite big. You have some areas with maybe less densely populated area. Do you also have like a strong increase of ground-mounted PV? I mean, what is the incentive to go for floating PV at the moment in India?
No incentive. At the moment, there is no incentive available to floating solar, and that is how the policy intervention is required. But one policy is there. If you have a solar, so transmission charges are waived off, number 1. But the owner of the water is somebody else. On the other hand, like for example, in Western India, we have less population called Rajasthan, where we have a lot of good solar sign. very, and also good land are available, huge lands available without any big use of water, because water is not much up there. It's like a desert area. But thing is, in water, the owner is different, and water comes the priority for drinking and irrigation. So when you want to go there for floating solar, so the owner does not allow immediately. He does not allow you immediately. There are no incentive available. On the other hand, having a large park of 7,000 megawatt is easy compared to do a 200 kilowatt, 500 kilo or 500 megawatt or 100 megawatt project in a floating solar. So, and there is a lot of variation of water. In India, the dam variation level is very high. In monsoon, it becomes very high, and then sometimes it goes very low. So that is also a big issue.
Yeah. But maybe that could be an interesting topic to study in the coming years to ease the development of floating PV, is to have experiment on evaporation data, because for those dam owner for irrigation and water supply, they don't want you to come to install floating PV because they're scared. But in the same time, if you could show them with sound data that they will save water and they will have more water to provide and to fulfill their services and to be more efficient, maybe that would help the discussion.
Very true. It has helped. I mean, it is trying to one of the argument for that. But unfortunately, since measuring the data only exclusively on the base of operation is quite difficult to assess, because you are only covering 5% or 10%. But argument-wise, in canal, people have measured it. In canal, when you cover the canal, then people are able to get more water on the downstream side. So people are making better management. But in terms of lake, as you said rightly, this is one of the arguments which is able to sell it out. I mean, this argument is quite positive, but still it is take times, because not much studies are available in terms of operation data. Okay, over to Professor Amit.
Yeah, if there are no questions, probably we can conclude. 1 second.
Yes, please.
Yeah, so with that, I would like to thank Ms. Marine again. Thank you for the talk, and thank you, Professor Arun Kumar, as well, for the nice discussion at the end. Today we come to the end of today's session. I thank Professor Singhal for his support, and I also thank my colleagues, last but not least the audience, the students, without whom this session wouldn't have been possible. Thank you one and all. In our next session, that is scheduled on August 18th, we'll hear more about the constructed wetlands. You can see the lecture series schedule on the for the entire year on the screen. So see you all on the August 18th at 5 p.m. Thank you all.
Marine, I just was asking if can we share your presentation with the attendees?
Yes.
Yes.
No problem.
No, your PDF version, can we upload in our so that people can share it?
Yeah, it's no problem for me.
Okay, fine. That's it. Thank you very much. And I think also we look forward that we could have also some kind of joint research, because there are many times a lot of calls come from the France government and Indian government together. So that is the time when we can have some joint research proposals also, And since you are engineering group, I think we also will be quite, we will be quite having a common interest or common, interest in writing joint proposals or something like that.
Sure. Yeah, we can keep in touch and discuss those topics, of course.
All right. Thank you very much, Marine, and I think Professor Amit, thank you very much, and let's, I think, say bye-bye.
Yes, sir. We'll call it up. Yes. Thank you.
Thank you.
Bye-bye.
Thank you.